Okay, as people are still joining, we're going to get started today with our roundtable. We have experts from TigerGraph and Expero today. The presentation is being recorded, so and we will send you the recording as well and a link to the slides after the webinar today. If you have any questions, please feel free to use the Q&A panel within Zoom versus using the chat. But if you have any issues with Zoom itself, please go ahead and chat with the host. And let's go ahead and get started. I'm going to go ahead and introduce, I think, Scott first.
Yeah, nice to meet everybody. So in today's session, we basically have three separate sections. What we're going to cover today is number one, why is this so challenging, right? So what about cyber? What are some of the technologies? Obviously, everybody cares quite incredibly now. And there are many different sort of faces to that. So what I'll be covering then is sort of the shape of the problem, lots of tools available today. And then I'll actually be giving a live demonstration. My counterpart, Dave Braun, on the technology side, will walk through now, how does Graph come to the party? What does it do? Specifically, how does it work? And why is it so incredibly exciting for what we're going to do? And then at the end, we'll hear from Michael Shaler, who's going to then talk a little bit about sort of what TigerGraph does specifically, and then more importantly, how can you get started and start solving some of these problems today? So lots of good stuff. And so with that, we'll just go ahead and jump in. So nice chronological order here, right? Don't need to tell anybody about this. However, lots of different types of things. So cyber means a lot to a lot of different people. It can mean malware. It can mean ransomware. It can mean simple ID theft, etc. And the biggest takeaway here is the money, the impact, the downtime, the opportunity cost, right? The numbers just on the actual ransom are only a fraction or a tip of that iceberg for what happens here. It's the disruption, it's the pain. In some cases, it's the fact that people that were considered walled fortresses are actually very accessible. And so it actually can cause trillions of dollars in damage to one's brand, not to mention sort of customer loyalty and some of the other items. But the bottom line is it's getting worse. And even though this sort of rift now in different softwares and lots of sort of overwhelming or dizzying technology, it continues to happen. And I think that's really the core takeaway. Why is this so bad, right? So a ransomware is not a simple act of somebody putting a gun to your head, right? It comes in a very different way. It can look something very unobtrusive. It could be a backdoor. And in this sort of little pictogram here is that once it gets in, it's starting to do things. And then how the money transfers and where it goes is actually very difficult. Now, some of the solutions that we'll show you today allow you in all of it. So stopping it from the beginning, identifying it and tracking it so that if there is law enforcement and where did it go and so forth, we'll see how that works and why graph databases are so incredibly unique and so incredibly powerful in what we do here. Again, when we look at this idea now for some of these different elements, then is the ransomware or software element is, again, sort of one step. It has to get through, it has to connect to, it has to get behind the firewall, and then it starts to do things. Well, that isn't, that's sort of a cascade of different events. What we'll find now is the graph database, when we start to look at these, and the traceability of that is incredible. Now, the ability to see a pattern that has been seen before, whether elsewhere or in your organization or other kinds of things, is also an incredibly powerful element. Now, lots of products out there do that today. And what we'll see today then is it's not just a one size fits all or a single bullet. There is no silver bullet. What we want to show then is how this recipe or capability of using a series of technologies is so incredibly powerful. Now, what is it that we do? Well, as a combined team, what we're going to see today is a solution that allows you on the left to do not only cyber, but many kinds of fraud. So typically what we see in our use cases and our customers, and some of these are the top banks out today, and whether you're financial or non-financial, we are working across the board in consumer goods, package, supply chain, as well as financial. But what we start to see now is there are multiple use cases, or in some cases, business units in your organization over on the left. So many times cyber or the malware entry is simply a tip of the spear to get into money launder, or steal credit card information, or create things where maybe you look like a good citizen and you're doing good things for some while, and all the while you're doing something even more nefarious, where a coordinated attack across all of these. And then even if you do find them, or you identify what they are and you go prosecute them, do you have enough information? What we're going to spend our time today on is really here in the middle, which is how does the regular human, how does the executive, how does the manager, how is the analyst, and then even down at the lowest level in the DevOps or those kind of people, how do all of those people see this quickly, take action to be able to do that? And then if I'm rerouting or shutting down or doing things, how do I now do a dependency network of blast radius and those kinds of things? And those are all very important. And then finally, how did I do that, right? The way that I can act over on the right now is finding those patterns, seeing those risks. And that's really what we're going to show today, is how do we do that in a very different way and collaborative. And again, what you're going to hear today is our technology is additive. We're not suggesting that it's a rip and replace. We're suggesting that in a very rapid period of time, we'll be able to do that. Now, let's look at some of these numbers, right? So some of our customers today are finding 20 or up to 50 to 60% for what these things look like. Now, they could be inside threats, they could be external, they could be cyber or malware, and finding some of these are in the $20 million. So one of our customers, in a very rapid and short period of time, basically avoided, in their own calculation, an approximate $20 million problem with the way they were sort of seeing things. And that was using the current data. So there's a lot of great capability to be gained here. And this is really how we start to see that, right? We see now that if you're using machine learning today, congratulations. There are many people today that are starting to dabble with it, but that's really the baseline. Now we bring that to you with our product, but if you're doing it today, congratulations. What we want to do now is move the bar up even further by using the capability of graph analytics, machine learning inside of the TigerGraph platform, is really an enormous one. And we see even higher than 6%, but that's really kind of the baseline. The other element is our friend, the human. Whether you're an analyst or somebody at the business level, being able to see it in a way that makes sense to you so that you can feed back into the training loop inside of a platform like this is really an incredible boost as well. Now, this doesn't even include the boost of productivity of being able to do more in a rapid period of time. Now, why do we want to do this now? Well, the bottom line is that, as we saw in that first slide, it's game changing. In some cases, it could cripple your business. It could put you out of business. So not doing it is really not an option. But why now would I augment with a graph database? It's the ability to do it in real time, less than 10 milliseconds. The ability to bolt on to any solution or technology that you have today is also that game changer. So able to sort of add and do that. And we'll see more about that here in a second. Now, who are you in that list? You heard me talk about who you might be. Now, what we can do here is we start to see that maybe with our user interface in the back end, we can set up data and data models. We can attenuate our machine learning. We can start to identify what those different elements are. And then as we move up the stack, you may have investigators, you may have people that are doing forensics, you may be doing alerts, you may be stopping things in the business side of the house. And that's really what TigerGraph is very unique in, is that we offer two parts. Now, you don't have to buy both parts, but what we're going to see today is what those do together, and more importantly, how they really sort of work in unison to go do that. So regardless of who you are in the organization, that's what we start to offer here. Now, there's some links here to go do that. But let's talk now about what we want to do. So in this case, we have the ability, and Dave's going to walk through sort of how we do it with the technology, but the ability to sense in a very smart way, use those machine learning algorithms for the human. And then in this sort of quick picture here, we're going to see a live demo, but it's the ability for that human, the investigator, the manager, the person whose special investigation or prosecution is to see where it came from. Number one, stop it, act on it immediately, and then identify the pattern and how to stop it going forward. And that's really what this is all about. And the other thing is there are many humans in your organization that interact with each other. How do we make that team stronger? How do we learn? So even if you have junior team members, right, how can they be as strong as your smartest team member? And the answer is, let's use this automation and the capability to do that. The other thing is you may already have user interfaces or softwares. This is designed to bolt into those. So if you have dashboards and Tableau or whatever it is, that's really how this works. Now, let's see how this fits together. The graph database, again, we're going to talk specifically, and Dave, is why the graph is so unique. But there are two parts to that, right? So there is the ability to connect relationships of data, IP addresses, MAC IDs, logons, all that kind of information over in the processing engine, right? And then I can store those links and start to make inferences. The second item now is I want to let this group of team members over on the right connect to that. And we may be integrating with your customer 360 data. We may be connecting to some of your downstream supply chain data. All of that information makes the richer capability inside of the graph even stronger and more accurate. And that's where the strength happens here in the middle with the algorithms and the alerts. Now, as we move, as we come over here, the point of this now is this solution from TigerGraph is to do just that. We want to increase the accuracy. You saw the numbers. They're quite exciting. Decrease the false positives. So don't give me a bunch of white rabbits to go chase. Use my technology, whatever your tech stack is, the ability to bolt on. Make it more efficient. So the same humans that you have today, make them more efficient. Let them spend time on things that matter. If there are changes that the government is throwing at us, there are some regulations about data and GDPR and those kinds of things, right? How does a solution like that help? And then the ability to be modular. If you just need the graph database, or if you need the graph and the different modules, right? And then most importantly, TigerGraph. TigerGraph is really the engine, sort of the race car engine, if you will, to our Indy car that we're talking about here. Now, what is inside of this? We come with these different modules. We can talk more about that when we see the technology, but it's flexible. The thing that our friends at Bank of America said was that on day number one, I have to stop fraud. I have to make this not be something that I deal with the day after. And every day that I'm not doing that, right, this flexibility or modularity is what they needed on day one. I had to be out of the box and running as fast as possible because there is no time to defend against the fraud. Now is the time. Now, what does that look like? What we're going to see then is Dave is going to walk us through these different interfaces. What I'm going to show you now is really over here on the right. How does the business user interact with what I find in TigerGraph? Dave and Michael are going to walk through sort of what we do on the back end and how do we set those up and how do we use those algorithm components. What you see now is in this style of a diagram here, you can see that we connect to multiple data sources. So whether it's a good list or a bad list, those are the kinds of things that we do. Now, in these user interfaces, what are the things that can happen? I can create recommendations to say, human, you should stop this. You should make this decision right now. Or I can come over here now and I can actually show where those things are happening and in time. And what I'm doing now is I don't have to show information that is not needed for a level 1 person. Make a stop, make a change, act on it. That's really what we're trying to show now, is whether it's in a real-time capability or even an after the fact, how do those things lay out? When did it happen? Were there connections that happened that seemed innocuous? Where do those things lay out? How do I see those? And how do I make understanding out of the fantastic things that happens in the back end with TigerGraph and the data and the connected information? This is now sort of drawing the picture for the human. Why did these things happen and at what time? That correlation is often very important. where in space did it happen in certain locations. In this case, I've decorated pictures and diagrams of things, and then you can see I have risk scores that draw my attention. So again, let's allow the rest of the business that capability to see with that information and make a determination quickly. Should I do something? Should I not do something? Which is part of that false positive capability. Then we start to get into where and at a forensic level or an atomic level that's so exciting with a graph database is what are those connections? What are the things that were not obvious? Some of our customers have said that, is that I have people that have been doing this for 15 or 20 years, and what's locked in their brain are these connected patterns, and I can't necessarily pull that out of a brain of a human, but with a graph database now, I can see it, I can make sense of it. And the way a graph database works is it works the way our brain does. It shows things as they're connected, and then those non-obvious relationships. That really is the most important thing in trying to find some of these detailed kinds of things. Now, I'll pop up a quick demo here. In this case, what we now see is, again, a dashboard. Now, TigerGraph is not in the dashboard business, but you may have Tableau or other kinds of things. What I want to see now is that if you have an existing dashboard or if you use our dashboard, that's great. But this is someone who would be a level 1 alert analyst. And what they would do now is they would say, well, I see where these alerts are coming from. I can see different kinds of things. And again, this is very configurable. I can look for individuals or certain types of things. But what I start to see now is here in the center, I see a host that's sending those connections. Well, look what I've done. I now can actually come in and I can start to, sorry, my screen was a little too small. I can come in and see where that happened. Now, obviously this is bad. This host is under some sort of attack. I can start to interrogate that. I can see that, well, these emails are connected to this host, and then I see accounts. Well, how far has this gone? I see a risk. Obviously, that's probably bad. But what I can do now is I can start to build something called an alert. And some of you may have alert systems. But what we saw in that previous diagram is that TigerGraph can augment your current alert. So if you have hundreds of rules in some other kind of a system or wherever they may sit, the graph analytic rule can sit next to that or work together so that now I can get that accuracy. So let's see how we do that. Now, in our screen, what we see then is I could set up this joint or a combined alert. And what I can do now is I can go in and look at Boolean data, or I can look at graph algorithm data. In this case, my first trigger shows that I have now a URL that I know is bad. I can also see that there is something called Louvain. And for those of you that are ML team members, again, Dave's going to talk a little bit about that, but that is showing connections to known fraud within a degree of separation. So find a community or connection. And I can do more kinds of those that we see here in a minute. Now I can say when I connected Scott, and in that previous diagram, we saw a person that was there. What is his entity? Is he in multiple systems? Does he have 10 logons, right? What is that? I want to make sure that that person is exactly who you say you are. What is the similarity to existing or known fraud? And then perhaps other kinds of things like ranking or then geography. So I can attenuate now my model, and then I can pick an action. What do I want to happen? I want to immediately shut it down. I want to shut it down. And in this case, I want to send it to a dashboard so that a person can interrogate it. Then what I can do is I can see what those are inside of TigerGraph. And now what I get is the next time I see this, I see an attenuated find. I can see that that host spawned an email that got into an account. And now what I start to see then is this account appears to start doing things in subsystems that are not normal. I see a mass file rename. Well, guess what that is? That's probably a ransomware, right? And there's high volume of those kinds of things. So what I can do now is I can drill in and say, show me that time view, right? So I want to see where those things happen. Well, in this case, I can see that he had access to multiple systems. I can see that somebody appeared to penetrate, and then sure enough, he's actually on vacation, and then suddenly this activity happened. Well, I would have created an alert that would have actually stopped that and shut down those kinds of things before I got to this point. And that's really what we're trying to do now, is start to create this attenuation to go do that. The second thing that I can do is I can now dig in deeper, and I can say, well, what was that file that was transferred? Now I can start to say, well, this file, again, a graph style equation, I can see what it does. It's certified, it came from an IP address, it's doing things, it's replicating, it's communicating with Google. And then finally, I can identify branches inside of that piece of software to say, well, that is something that we have seen previously, and absolutely it's malicious, but I can do that now in 10 milliseconds, right? So the power of this system is to be able to do that. So again, this was only a quick trip for what we do here, and hopefully that was useful. With that, I'll hand it over to you, Dave. Dave, if you're talking, you may be on mute.
Sorry about that. So thank you very much. I'm going to continue where Scott left off, talk a little bit about the machine learning side of this, as well as how that ties to cybersecurity and all of what you're dealing with as it relates to graph and your environment, and using your tools to make more value out of the investments that you've already made. So when you start looking at machine learning, algorithm support, you've got everything from clustering, you've got between this, you've got graph convolutional networks. All of these different types of machine learning allow you to start building in patterns. When you're building in the patterns, it's giving you the ability to understand how things are laid out inside of your network. So between this, you're looking at how close are certain things. Do you have a potentially infected entity that is starting to have conversations or move data, or starting to in some way push out, say, a payload to different systems inside of your environment? You can look at similarity to see if you're seeing it's been attacked in multiple locations. Therefore, now you've got the same activity going on in multiple different areas. So you've got similar activity using a similarity algorithm. When you start looking at shortest path is going to help you understand where exactly are you and where is this attack, and how is it in relation to, or the shortest path to, let's say, one of your more high-end systems, whether it's your financial system or whether it's a customer data system, whatever. You want to be able to identify these things, because all of this is tied back to what we all know in the security world, the MITRE ATT&CK framework, understanding how all of that works. Scott, if you could go ahead one slide for me. So when we think about it from the algorithms as it relates to cyber, when we start dealing with Levenstein or with Louvain, you have the ability to really start looking at dependencies, you're looking at failure chains, you're looking at how things are closely clustered together or in similar activities. The paths or patterns are the same, and that helps you understand what are people doing, what is an anomaly. As with any solution, you have to set a baseline that gives you an identification of exactly what your baseline is. And then you start watching for things that are out of the norm, things that are coming up, whether it is, the flow of data, and you suddenly see data veering off into an area it shouldn't be going. You see someone culling data. Think about back, one of the most prevalent breaches in news history was the Target breach. When they were attacked, they weren't attacked from inside their network. It came from a partner's network. Once that got into the target network, they started culling data together, collecting and pulling that data together into a centralized location. So looking for things like flow, looking at things like similarity, we're noticing this data is being collected and stored in one area. Why is that? That's not normal. Looking for categorization, understanding that you have sensitive data, you have user escalation for privileges. All of this is starting to happen, and you're looking for the dependencies of saying, this is the order by which it should be happening, but something has changed. So if it's changed, we need to do something about it. Go ahead and move forward. So think about it from the standpoint of your current investments. You guys have made a lot of investments in some very, very high-end tools. It could be an EDR, it could be an XDR, it could be an NDR, it could be a web tool, an email tool. You've made investment in SIMs. What's the number one problem with all of these tools? they don't talk to each other. So when you're trying to trace down those threats that are happening inside of your environment, one of the #1 problems that most companies deal with is something called alert fatigue. Alert fatigue is a very real thing. Let me explain to you what we mean when we're talking about how we're going to help you with a graph perspective. In a SIM will pull data from some of these tools, not all of them, unfortunately, but we'll pull from some of these tools. When it pulls that data in, if that threat has touched, let's say, 5 of your different solutions, the SIM will see it as 5 separate attacks. That's not correct. It's one threat that's moved across multiple tools. It's done everything from culling of data. It's done privilege escalation. It's done whatever it has happened to do during a certain period of time, and you start seeing all that activity as separate threats. That's not separate threats. It's one. So the way that you reduce this is bring it together in graph. You integrate, pull all of this information in from all your different tools, from your SIM, from all of your network tools, all of your endpoint tools, all of your web tools. Bring that data in, and then we can apply multi-graph technology to it to allow you to see end to end, from egress to wherever it currently is at within that MITRE ATT&CK framework. It's going to identify all the different things that have been going on, and the similarity of those different threats will be identified as a single chain and allow you to actually see what's going on. Once you take it to the next step, and you, as Scott mentioned, you've went through and you started working with this. So let's say you've got your access data coming in, you've got customer account information being fed into there. We can take all of that activity that's going on and then get the feed from all of your network tools. That's where you're going to see on the bottom left-hand side, your IT developers, your IT engineers, your SOC analysts, your NOC analysts. They're going to look at this TigerGraph Graph Studio, and you have the ability to start dealing with the actual algorithms. You can start working with those queries to determine exactly how you want to identify a particular threat, and what do you want to do once a threat has been identified. Do you want to send it off to a SOAR? Do you want to alert someone? Do you want to do something else? The other side of it is when you start getting into your executives, you get into your high-end business users, you get into certain investigators, you get into some of your auditors, they're going to want to see dashboards. They're going to want to see what Scott was showing you before to be able to get a high-level overview of what kind of threats do we have coming in? Are they geographically inside the US? Are they coming in from different locations around the globe? What is the type of attack that we're getting? And that's where the workbench starts to provide that additional value to you. Using the business logic model, the graph model, and the ML model together, that allows you to start really doing some deep link analytics and understand the exact location and effect of a particular breach, of a particular threat. By understanding that, what you're going to see here is with the Expero solution, you start doing your entity resolution. You're going to start doing your API connectivity, and it allows you to pull that information through. You can understand from the UI interface with the toolkit, it's going to give you a better view, a better visibility into what's happening, when it's happening, and allow you to respond to it in those sub-second response times, in those milliseconds. By doing the data mapping and the source mapping, you actually have the capability to really start digging in and understanding from your source data, what was this system that was being attacked? Was it a mail system? Was it something that was as simple as a malware attack? Keep in mind, when people are going out and they're attacking a system, they're not going to come into your environment and hit it right away. They're going to start moving around. They're going to do lateral movement. So you need the connected data to be able to feed properly into exactly what you're doing. Seeing that server information, seeing the user information, your resource and your system logs, all of this key information is going to be critical for you to properly identify where an attack started, where it's been, and what has it been doing. So think about it from this perspective. When we think about it from threat detection and response, You notice in the top right-hand corner, the orange block around that user. We've got a user that reports to someone and suddenly that person is not there, but all of a sudden they become part of a group. Once they become part of a group, they find out that group has administrative privileges to some of the microservices running on your environment. As it takes to start working with those different systems, it starts to collect data. As it pulls that data together, it starts pushing it towards exfiltration to a URL. That fires off an alert. What we have the capability of doing is within those microseconds, see this pattern of activity, pattern of user movement, and do something about it. Proactively alert you and let you know what's going on. So the graph will do that analytics and identify everything that's going on. Using the API, we push that information out to your SOAR that you've already invested in, and it starts doing that behavioral analysis. It starts letting you actually put in place the response that you need. When you think about it, we want to identify the vector types. We want to understand exactly what's going on. So in other words, as you see here, we have an endpoint that injects a file. It's been infected somewhere. Keep in mind, it's become more prolific during this worldwide pandemic for people to be working from home. And let's be honest, how many of you have allowed a family member to get on your work computer to go to Amazon, to do a little online shopping, to do schoolwork, to do other things that are not business related, and allowing that machine to actually have access to things that it really shouldn't have, that could potentially bring in malware, that could bring in other types of threats, that now through that VPN tunnel, you have many customers that will tell you, oh yeah, we're protected, we have a VPN tunnel. Well, that's great. Now they've got a secure way of getting to your network. So you want to be able to do that tracing. You want to be able to understand exactly where the threats are coming in. Once you've identified that, let's say, code injection, and you see it moving across the network with your network transmission, you can identify what users and what systems are being infected or affected by that particular threat. When you think about the blast radius of an attack, your nodes are your endpoints, their servers, your IoT devices, network devices, everything else. These are the entities that are being attacked, that are being sought after. We can identify them, and through the algorithms, through different styles of algorithms, we can actually do identification of those different activities and look for things that are anomalous in your different devices. The edges are the lines or the connections. It's the communications and traffic flow in your network. So it's those relationships that help you understand this server is connected to this router, that's connected to this workstation, that's connected to this mail system. And that's how they walk through your network to get to your mail system to plant a piece of malware. The node size is relative to its connectedness, and it will allow you to understand what the vulnerability of other endpoints in that immediate area could be. So you have a blast radius, you have an area that could be affected by this potential threat. When we're doing anomaly detection, we're really trying to understand with the behavioral analysis, the pattern matching, doing all the different things that we do within the graph. We have the ability to start looking for everything from flooding detection, DDoS attacks, footprinting detection, phishing, and so on. The data mining, the user exploitation, the lateral movement, all of these different types and styles of attacks can be going on simultaneously. So you'll notice on the top left-hand side, your anomaly risk, you can move that slide bar to really focus in on, I just want to see the medium and high, or I want to see just the high. So you can start narrowing it down to identify, these are the ones that I have to worry about today, right now, to see what's going on and can we properly respond to the threats that were being tossed at us. When you think about endpoint identity lookalikes, whenever an attacker comes into your environment, they're going to go in and they're going to be looking for something called metadata or breadcrumbs. That metadata is planted on every single machine across the globe. Everybody has it. Basically, what that metadata does is it identifies all the things that you've been to, all the things that you've connected to, you've traded data with, you've logged into, whatever, whether it's a web system, an application, a server, a network device, it doesn't matter. Anything that you go to is going to be there. So when you start noticing the similarities in different metadata that exists out there, you start seeing this birds of a feather flocking together. You'll see all of these different users that build a community. They're endpoint identity lookalikes. When they do that, it allows that bad actor to actually start duplicating some of that activity. So when you have highly suspect endpoints, they look similar. They're in a highly dense area, a high dimensional space that gives them the ability to look very similar. Those bad actors can then start identifying their most valuable targets much easier. That's where the Louvain communities and the kernelized PCA allow us to do some further in-depth analysis to understand where are your most at-risk communities, where are the user groups that could be potential high risk that we need to start working with additional technology to try and protect it. Lastly, when you start thinking about structured threat detection is all about identifying an entry point. You have to try and identify where did it actually come in. How many times have you heard of an attack where someone has said, you know, I got attacked 3 months ago and then now we're getting attacked again? Well, no, you're not. They attacked you, you found them, they backed up and hid inside your network until you thought they were gone, and then they repivoted out inside your environment. They did lateral movements again and started attacking. They never left because you never found their original egress point. You've got to be able to do that. And with the different types of algorithms that we provide you, you can use the technology that you've purchased, that you've invested in, that you've got in place today to start understanding what are the different systems that have been affected by this particular item, this attack, malware, ransomware, whatever it is. When you think about it from a fraud perspective, you're looking for identity lookalikes. So fraud is nothing more than emulation. They're trying to look like something that they're not so that they can get the same type of activity that a normal user would get, whether it's getting money, whether it's getting a rebate, whether it's getting special privileges, whatever that is, it's those similarities. And it's that clustering of users into a group area that allow you to take that fraud identity lookalike, and then you have the ability to really start digging in and understanding where could your bad actors be hiding or trying to get into that community, into that group of individuals. It starts to identify for you your high risk areas, your average, your low risk areas, so that you know what to be aware of and where to look first. Because in the sea of all the alerts and notifications that you're getting, you have to be able to identify the things that are most at risk or your highest risk as quickly as possible. The proactive attack prevention comes from the ability for you to identify where that stuff is happening. So understanding the shortest path to your blacklisted users or your IPs, having a K-nearest neighbor identification to understand where is my potential threat, a bad actor or a known infected machine in comparison to a sensitive system, whether it's financial data, customer data, employee data, it doesn't matter. Understanding where that stuff is at and understanding how to identify where the path of data flow is happening so that you can quickly identify where that threat's coming at you. When you think about detailed steps in the prediction process, you really have to start by doing the simplest pieces of it. Feature extraction from the graph showing its performance under different conditions. You can see that here. We have projection into a retail customer fraud graph so we can identify where the customer fraud is happening, we can start identifying the things that are anomalous or abnormal user activity when it comes to customer purchases or shipping information changing or purchase information changing, having the person buying using someone else's credit card, whatever the case happens to be. But it gives you, through machine learning, we can start picking up on those different anomalies and proactively doing something about it. So having those hidden layer of information gives you the capability to really start digging in and understanding exactly where those potential threats are. Is there a potential fraud act happening where your users are touching data, where your users are sharing information, and then suddenly you identify that you've got a bad actor and they're collecting stuff and using that to go out and commit fraud? Identifying the hiding in plain sight. Think about it like this. When people are bad actors, when they're out there trying to hide, they're going to be right out in the open. The reason they're going to be out in the open is because they know a pattern of user activity. They've learned a little bit about your environment. As soon as they learn a little bit about it, they can hide in plain sight and you won't pick them out because there's so many alerts, there's so much information coming in, it's flooding into you. Without the graph functionality, it makes it almost impossible for you to truly identify who's bad and who's not. If they use similarity, if they use some of the tactics that you typically see in ransomware attacks, in malware attacks, in other types of activity, you start to find that fraud, that threat, that attack can actually be happening right under your nose. You'll have no idea what's going on. Going back to the Target breach, they were seeing servers fill up with data. Instead of seeing that as an anomaly that they need to check into, they added more disk. Thank you. That bad actor had plenty of space now. You need to identify those unusual activities to find those threats. So with that, I'm going to go ahead and turn it over to Michael and let him cover his area.
Thank you, David. Thank you, Scott. I just wanted to kind of highlight, where we've been in our, in this conversation thus far is that, we're highlighting kind of the urgency of this now. Why, the current set of tools that, David talked about, in terms of, the investments that were made were necessary, but are not sufficient. And what I want to go into a little more deeply, based on some of the things that David just said, is that, we actually have a unique approach to how we can answer questions that can't be answered by any other means. And so, we feel very grateful to be recognized by analysts like Forrester saying, hey, we're a leader in graph data platforms. But what's really, unique about us is a couple things. One is, we're the first scalable graph database for the enterprise. Cloud native, and we can deploy anywhere, on-prem or, in any of the clouds. We were founded in 2012. We were in stealth mode for 5 years. We're based in Silicon Valley. But the crown jewels of what we do is a language that makes a lot of other things possible. It's our architecture and it's our language. And GSQL, graph structured query language, is like SQL. Select star where works, but it enables us to do, not just graph algorithms, but it also allows us to do breakthrough AI and ML. And some of the algorithms that David was referring to and that Scott showed in action are really kind of where the magic happens. So I think the summary is that we answer the best questions about connected data with fast, deep, and wide insights. So let's go to the next slide real quick, please. This is kind of our variation of the OODA loop. Where in the Air Force they I forget, it was general. It's observe, orient, decide, and act. But we see, connect, and act, and we want to be able to help our customers combat and overcome fraud, and when make sure that, like Scott said, when we have enough information to prosecute crime rings, we can actually, take the win home. We can protect not just our customers, but our customers' customers as well. So see, connect, act is how we think about this. Next slide, please. And so Tiger Shield CyberFocus is all about, increasing the accuracy. And we heard from Scott, we increase we were able to boost our models and we were able to boost our insights for better accuracy with fewer false positives, we can span existing technology sets, and we can actually add value to them without rip and replace. We can increase your speed and efficiency. We can adapt to changes. We're going to see a lot of regulatory transformations occur in the next several years as the government starts to catch up with where criminals are headed. And so we can actually intercept them. It's a modular total solution. So the graph database plus the visualization componentry and the machine learning all fit together really, really well. It's powered by TigerGraph, and we're excited to be able to share this with you today. Next slide. We're not the only ones excited. Gartner is especially Rita Salem, who's one of our most important analysts. You know, she highlights how much graph relates everything. Now that touches on all sorts of, you know, so the top trends. We touch into all of them, but you know, we're able to deliver a new set of breakthrough data and analytics capabilities for cybersecurity as well. So again, we can see, connect, and act in a very unique way. Next slide, please. When we start to, as a build, yeah. So we first of all, we connect all the data pipelines together, and we can actually, we have one customer who's bringing in data from 200 different sources to be able to be processed in real time. So you have a significant ingress of data sources and insights. And click. And then we can also, you know, do real analytics. We can look into it and see better than we can with other tools. We can answer questions we can't answer by any other means. And then click. We can also learn from that. We can do it in database machine learning. And that's different. And you know, combining graph algorithms plus machine learning builds this insight flywheel that you can't have, you know, you can't find any other place but TigerGraph with Expero. Next slide. So, you know, again, let's double click on kind of what we mean when we say see, connect, and act. First, we're going to build, you know, the enriched advanced persistent threat forensics graph. We're going to enrich that graph with external apps and data sources. We're going to connect deeper with human exploratory learning, which means that we're always going to have humans in the loop, but we also have the ability to add unsupervised learning. We can actually characterize data in terms of connections, groupings, communities, patterns, outliers, and we can actually then start to add weighting for risk and anomalous behaviors. Then we can actually extract forensic graph features, and then we can train our machine learning model in the graph by doing machine learning in the database. Next slide, please. So how do graph analytics work? It's all about connected data. So Scott mentioned earlier in the presentation about the ransomware threat. Scripps Hospital as a chain, you know, was affected deeply by that. Colonial, the gas pipeline was affected by that, and we're able to identify kind of all the entities, as David said, in terms of how that data is connected, how behavior is connected, and then how we can actually build insights into what keeps the bad guys, you know, kind of how we can identify them, and then how we can prevent them from doing further damage. That keeps our customers and our customers of customers safe. Next slide. In terms of scale, we actually can scale to any workload size that we know about. And so we can actually, we're on our way to petabytes, and we can scale out because we have an architecture that enables horizontal scalability. We can also then take advantage of all the cores that are underneath us and all those servers to actually, you know, deliver the massively parallel processing. So performance scales with size. That means we can actually build, you know, customer 360 hubs. We can actually then, as a next door neighbor, start to look at, you know, what we can do from a cybersecurity perspective across all those endpoints with all of those, all that surface area. And then we can identify blast radius from there. Next slide. In terms of the real-time deep exploration, we can actually deliver actual insights by looking across all these systems, all these endpoints, all these vulnerabilities, and then enable that to be understood in context. Non-obvious relationships are powerful when it comes to cybersecurity. That also means we can take on real-time queries and updates. We can take all those updates from those 200 systems that our customers are using today to actually update our graph and then apply those insights as the context evolves. So this exploratory capability plus the visualization plus the machine learning is all supported by Graph. Next slide. So when we think about the combination of analytics and machine learning, we actually are able to customize the graph algorithms that go with it. We have open sourced all of our graph algorithms. We have over 50 on GitHub, and we have, as an example, we can do PageRank for community detection. We can find out who are the key influencers, and that can be a positive thing in terms of here is the leader in a given community. It can also be the ringleader of a crime ring. So we need to be smart about kind of identifying who are the good guys, who are the bad guys, how do we tell the difference? Algorithms help us make that happen. Now, we also are able to support lots of different languages and lots of different engines in terms of how we are able to integrate our graph database with other machine learning frameworks and other security tools, all the SIMs, all the XDRs, all the rest. We're able to stitch that together in a comprehensive view of all of your vulnerabilities, all your endpoints, but also all of the good guys and bad guys. So it's powerful and it's compelling and it's complete. Next slide. Our difference is that we have the ability to do lots and lots of hops from a real-time deep link querying perspective. We have significant design differences, and those translate into benefits that customers can relate to. We can find hard to find patterns. We can handle scale in terms of integrating all the data with automatic partitioning, with elastic scaling resource. We can do all of that. We do in-database analytics and machine learning. We have GSQL on our side. We have graph algorithms. We also have the ability to do both OLTP and OLAP. Both matter for cybersecurity. And then the last one is we're able to build no-code visualizations from migrating data from relational databases or SIMs or other data sources, any data warehouse, any data repository, any application. And we can bring that in through our REST APIs and through through Kafka, through Spark, et cetera. So we're able to democratize self-serve analytics, enable all your teams to be more successful in trying to build a more aggressive cybersecurity stance. Next slide. So TigerGraph Cloud is a great way to get started. You can get started for free there, and we're excited to be able to invite you to give that a try. Next slide. I think that's the last slide. We have all the places where to start. Both our website and Expero's website. We have toolkits that we can leverage, and we can also spend some time with you in a conversation as well. Next slide. I think that's it. Yep. Thank you very much, Scott. Yeah. So I wanted to now kind of highlight, kind of what questions did we hear during this conversation, and kind of how can we address those?
Looks like I've got one here. Looks like it may be for you, David. I've got some Splunk information and some RDBMS data feeds. How much data do I need to start?
There's no limit on the amount to start with, as long as you have, it could be megs of data, it could be gigs of data, depends on what your environment size is. There's something we can sit down and do a sizing conversation with you to help you understand how best to feed the data in.
Okay, it looks like we've got a second question. This one may be for you, Michael, which is, in order to use my technology with what I have today, you mentioned that, how would that work in either my environment or a cloud?
The irony is there's no difference. We operate the same in the cloud as we do in on-prem environments. The only advantage, or the key advantage, obviously, we have from a cloud perspective is that's kind of where a lot of the data lives. Data that's cloud, born in the cloud, we can process in the cloud very fast. Some customers are less comfortable with, kind of some of the operational and compliance considerations that go with cloud. We can support them on-prem as well. So we can connect to any of your systems on-prem. We can connect with any of your SIMs, any of your existing capabilities, and then we can also extend that capability with Graph. So the summary is, we will help you solve your problems wherever they exist.
Super. We've got one question. I guess I'll throw it to either one of you or both you and Dave. I would like to get started. Is there a place where I can look at how the data and the data model work together, and how would I do that?
So as Michael showed on the last slide that he had up there, there's different places on the website. So there's a link on our main website for TigerGraph that says getting started. You can click on that link. It'll take you to two different areas. So we have some starter kits with YouTube videos that walk you through and show you the product, as well as getting that basic information going. And then we also have tgcloud.io that allows you to go in, and there's roughly 20 different systems out there that you can play with and learn different algorithms, different ways to bring data in, and so on. And then obviously the final thing that we can offer you is working with our friends at Expero to work with their environment to get their system connected to that demo environment that you're working with.
Super. And the last question, that's one that I can take. The user interface that you showed seems to have a seamless connection with TigerGraph. How does that work? So what we saw today was really two sides of the same coin. So if you're interested, you can obviously contact or reach out to us, but ultimately what's happening inside of the backend and TigerGraph is the magic for those queries and the algorithms, and that user interface is really designed to literally plug and play to show that connection, that algorithm, that exploration, but in a much more contained world. So it literally plugs in. And then there's also an extension capability with an SDK, and that comes as part of the package, or it's modular. So if you just need the backend and TigerGraph to do that, you can do that. Or if you want the entire solution, it's all turnkey if you need it, or it's capable to be extended. So it's really kind of, we like to meet you where you're at. Okay. Any other questions out there? Okay, I don't see any popping in here. With that, it looks like we're good on questions, and thank everybody so much for the time, and happy holidays, and have a great season. Thanks, everybody.
Thank you so much.
Thanks, everybody.